Dear students, for today we'll see what do we mean by active bandpass filter in the active filter section of analog electronic circuits. So here you can see the heading will be active bandpass filter. Now it will be a bandpass filter along with an active device for amplification. So your filtering action will be done by RNC circuits only, but the active device which you are going to use like op-amp or BJT, now in this case we'll be using op-amp, it is used for amplification process because the output of passive filter, that is a filter which is built using RNC circuit, will be very low, and to amplify that output we are going to use an active device, and that is why the complete filter will be called as an active filter. Okay. Now, basically, if you go to see what is a filter, now filter is a frequency selective network. A filter is a device that passes electric signals at certain frequencies or frequency ranges, whichever you are desiring to pass, and it will stop all other frequencies. Then, in that, if you go to see the types of filters, you can have low pass filter, you can have high pass filter, you can have band pass filter, and you can have band elimination filter. And today we are going to see what is band pass filter. Now, a band pass filter basically, even if you built it with the help of RNC circuit, it is a filter. Okay, it is a band pass filter, which is also known as BPF or pass band filter. It is defined as a device or circuit that allows frequencies within a specific range, within a specific frequency range, and rejects or stops or attenuates the frequencies outside that range. So we will be having two cutoff frequencies here. One will be named as FL and the other will be named as FH. And the frequencies between FL and FH will be passed, and the frequencies below FL and above FH will be stopped. That is what we have to show here as far as the definition is concerned. Okay, so say this is a graph of frequency versus gain. This is frequency and this is gain. Then you will be having one cutoff frequency here and another cutoff frequency here. So this can be called as FL, this can be called as FH, and then this will be your pass band. All the frequencies between FL and FH will be passed. Frequencies below FL will be stopped. This will be stop band, and frequency above FH will be stopped. This will be stopped. So a desired band of frequency we are going to pass. So this is a desired band of frequency, and the value of FL and FH will depend upon the RC components which you use in the circuit. So those are the two cutoff frequencies. Then if you go to see the bandpass filter technique, then you can realize a bandpass filter by using a high pass filter and a low pass filter. So here, as we have shown, the input is first connected to a high pass filter. Okay, now this high pass filter will be a passive high pass filter with a capacitance in series with the input, and then you have a resistance parallel with the input, and here you can get the output again. Okay, so this will be your input, and this will be your C1, say this will be your R1. Okay, and this cutoff frequency will be your FL, which will be equal to 1 by 2 pi R1 C1. Okay, then after having a high pass filtering, that if frequency above FL are passed, then you are having a amplification process either by op-amp. You can have op-amp here, or you can also use BJT here. That is an active device which can amplify, and hence the name active filters will come into picture. And after that, you have a low pass filter which will have resistance in series and capacitance in parallel, and here you have your output. So here you will have your input, and here you will have your output. This is ground, and this you can take it as R2 C2, and here you can have a cutoff frequency FH is equal to 1 by 2 pi R2 C2. Okay, now this, if you're realizing and if you want to see the graph of it, okay, so here you can see for high pass filter you are giving a graph, say graph of frequency versus gain. If you think about an ideal graph, then say this is your cutoff frequency FL, and this is your pass band. This everything is passed and this is stopped. Okay, this is from 0 to FL is stopped, and then you're passing. Then you're going to amplify here. Here you're going to amplify with the op amp. Okay, and after amplification, you are doing low pass filtering. Low pass filtering we are going to do like this. Okay, that is, it will start and it will end. Okay, now this ending point, okay, will be called as FH, that is high pass frequency. Now what we will do is, earlier what low pass, earlier what high pass filtering we got, okay, this was our earlier high pass filter. Okay, so this was your stop band, this was pass band. Okay, now here this was your frequency FL, cutoff frequency. Now we will start our low pass action from here, and we will go till low pass action till here FH. Okay, that means this band of frequencies will be passed. This will be pass band. This will be stop band, and above that also will be stop band. So frequencies between FL and FH will be passed, and frequencies below FL will be stopped, and above FH will be passed. Okay. So the low pass filter is used to isolate the signals which have frequencies higher than the cutoff frequency. Similarly, the high pass filter is used to isolate the signals which have frequencies lower than the cutoff frequency. So here if you see in a circuit diagram way, same block diagram we have converted into circuit diagram. So here you can see the input. First you can see a high pass filter here. So here you can see a high pass filter. So this is your high pass filter where a capacitor C1 is in series with the input and R1 is in parallel with the input. And here the cutoff frequency will be FL is equal to 1 by 2 pi R1 C1. Okay. And then that output of high pass filtering is amplified by an op amp over here. Now the gain of the op amp will be decided by this feedback resistor and this resistor R3, and then that output is again low pass filtered by a resistance in series with the input and capacitance in parallel with the uh, input, and that output you are going to get with the low pass filtering. Now this low pass filtering is a combination with high pass filtering. Now here for this low pass filtering, the cutoff frequency will be FH, which will be 1 by 2 pi R2 C2. Okay, now this low pass filtering and high pass filtering will decide uh, cutoff frequency FL and FH, so that all the frequencies between FL and FH will be passed, and the frequencies below FL and above FH will be stopped or attenuated. So you are passing a desired band of frequency. So again, in terms of graph, if you see, if you are having a graph of frequency versus gain, so here you can see you are having a graph here. So this is your y-axis. Y-axis is shown as gain. So this is your gain and this is your frequency. So here you are having a high pass filtering. So from the maximum gain you come down to minus 3 decibels. That is a half power point where you can get a cutoff frequency FL here. Okay, and this will be your pass band and this will be your stop band. Okay, similarly if you're having low pass filtering, then from FL, okay, you will have till FH. This will be your pass band, this will be your pass band, and this will be your stop band. Okay, now this will be your low pass filtering. Now again here you have taken from maximum gain to minus 3 decibel gain, and you have marked a pointer, and that you have taken as frequency. Now, if you combine these two actions, you are getting a band pass filter here. So this is your maximum gain. So this is again gain versus frequency graph. Gain versus frequency graph. This is maximum gain. Okay, and you are coming to minus 3 decibels, that is half power points. So here you will get the cutoff frequency of high pass filter, and here you will get the cutoff frequency of low pass filter. So this band of frequencies is passed. This is your pass band, and here you can have your stop band, and here you can have your stop band. So you're passing a certain desired band of frequency. So the a band pass filter or cutoff frequencies, as I've told you, the answers for the formulas for the cutoff frequency is given as, the band pass filter is a combination of filters. Therefore, it has two cutoff frequencies. One, a cutoff frequency is derived from the high pass filter and is denoted as FL. The filter allows the signal which has the frequencies more than FL. The value of FL is calculated from the below formula. This we have seen. FL is equal to 1 by 2 pi R1 C1. So R and C are the components which are helping you to do the high pass filtering. Then the second cutoff frequency is derived from the low pass filter and it is denoted as FH. The filter allows the signal which has frequencies lower than the FH. The value of FH is calculated from the below formula. FH is equal to 1 upon 2 pi R2 C2. Now again here R2 and C2 are the passive components which are helping you to do low pass filtering. So the filter operates between the frequencies FL and FH. The range between these two frequencies is known as bandwidth. Therefore, the bandwidth is defined as the below equation. Bandwidth is equal to FH minus FL. Now here, because we are taking that minus 3 decibel point, we can give you the bandwidth. So FH minus FL, that is the frequencies from FL to FH will be passed. And that is your bandwidth of this filter. Now here, if you see the graph again, a complete graph, the final graph of band pass filter. So here you can have your gain y-axis, and here you can have your frequency x-axis, and then here you are having your cutoff frequency of your high pass filter. Okay, and then here you are having your cutoff frequency of low pass filter. Okay, and then this is your bandwidth. From here you can see this is your bandwidth, because you have taken a point here from maximum gain to minus 3 decibels, and that point you have taken here as a cutoff frequency. Even here you have taken maximum gain to minus 3 decibels, and that point you are taking as a cutoff frequency, and all the frequencies between this part will be passed. Okay, will be passed, and this is your pass band, and the band below FL will be stop band, and the band above FH will be stop band. So you are passing a frequency from FH, that is from FL to FH, FL to FH, or you can say bandwidth is equal to FH minus FL. You can say bandwidth is equal to FH minus FL. Clear? So here we can see the stop band, pass band, and the stop band. This is your complete action of band pass filter. We can also realize the bandpass filter by having a complete high pass filtering using op amp and low pass filtering using op amp. So here we can use two op amps. So in the first circuit, we can see the high pass filtering is taking place here with this C and R, and this is your input, and it is given to a non-inverting terminal of the first op amp, that is A1 amplifier. Okay, now this is doing your high pass filtering, and in an amplified version you are going to get the output here. Now that output is given to a low pass filtering. So here you can have your R dash and C dash, which is going to give low pass filtering, and even that input is given to op amp non-inverting terminal, and that will be again amplified by the second op amp. Okay, so here the amplification of this second op amp depends upon this resistor RF dash and R1 dash. Amplification of first op amp will depend on this resistor RF and R1. So here we can use two amplifiers. We can use high pass filter in series with low pass filter to realize a band pass filter. And what circuit we saw earlier was using only one op amp for amplification. Now we can also use two op amps for amplification. We can have a separate high pass section and a separate low pass section, which we can combine and have a band pass filter. Then lastly, we'll come to the applications of band pass filter. Band pass filters are widely used in audio amplifier circuits. For example, the speaker is used to play only a desired range of frequencies and ignore the rest of the frequencies. It is used in optics like lasers, etc. These filters are used in a communication system for choosing the signals with a particular bandwidth. It is used in audio signal processing. It is also used to optimize the signal to noise ratio and sensitivity of the receiver. Okay, so these were some of the applications of bandpass filter. Thank you, students.